Hey friends, we are going to continue on. I'm making this video before school, so I'm just going to kind of cram in whatever I can before people are clamoring to get into my classroom and learn really fun things. All right, this is the kind of gist of the next section, which is how do you feel about exponential curves and understanding their shapes. So keep in mind, in this situation, you have growth where it's increasing from left to right. Your A is a positive value, doesn't matter if it's 3. And then your B is greater than 0, and, excuse me, it's actually greater than 1, sorry. So in that scenario, I'm going to have growth increasing from left to right. Now keep in mind that this is increasing because it's going up from left to right, but it's also increasing at an increasing rate because this one is concave up. Okay, so in this scenario, because this is negative, it's been reflected over the x, so now this is actually decreasing, and because it's concave down, it's decreasing at a decreasing rate. We are still in a scenario where b is greater than 1, but our a is less than 0 in this situation. Sometimes I find it easier to draw the original graph like up above. So like 2 to a power would have been a growth, and then flip it over to get an idea of what it's looking like. So keep in mind that this right end is approaching negative infinity. This right end is approaching 0. And with these exponentials, one of the ends is always approaching 0. Here my left end is approaching 0 and my right end is approaching infinity. So be able to understand that and express that, whether they call the right end x is increasing without bound, or they write it as the limit of the function as x approaches infinity. However they identify it, you need to be able to say, hey, that one's going to 0. Here, if they say x is decreasing without bound, that's left. Or if they say limit as x approaches negative infinity, that's left. And in this case, the left end's going up, so my answer would be infinity. In this scenario, my A is positive, so it's going to be above the x-axis, but my B is less than 1, which it's always positive, but it's less than 1, so this is going to be a situation of decay. It's going to come down from left to right. So this one is decreasing, but this is decreasing at an increasing rate, meaning concave up. And then this last guy, we have a negative A value. Our B is still between 1 and 0. So again, if I had drawn this originally, it would have looked like that, except better. And then I would have flipped it over to become what you see. Now keep in mind that this one is increasing because as I travel, the Y values are going up, but it's increasing at a decreasing rate because it's concave down. So keep that all in mind. This is my right end. My right end, or the limit as x goes to infinity, or as x increases without bound, is going towards 0. And here, my left end, or as x decreases without bound, or limit as x goes to negative infinity, that's going down, so that will approach negative infinity. So those are all the things you kind of have to know and feel confident about. So here we have a multiple choice. The graph of f is shown, which could be an expression for f. Okay, so first of all, this is above the x-axis, so I need an a to be positive, so I can rule out these two options. And then it is decreasing, and it is decreasing from left to right, so b has to be between 1 and 0. So here my choice is 1/3, and here my choice is 3. So I have to go with C on this one. It's the only one that would meet the criteria. Okay, we see this all the time, so be prepared to do this. We are given a table. It tells you it's exponential, and it's defined by this function. A and B are positive, okay? So the table gives values, g of x, meaning y's, at selected values. Which of the following statements is true? Okay, well, keep in mind that A is your value at 0. And so we have a positive A at 72. They already told us that, but that also doesn't help us because all of these say so. As you look at these numbers are decreasing. And so this is going to be an exponential decay. So both of these have to be eliminated based on the fact that they are not decay. And then if you look, what's happening, these are dividing by 3. So they have a multiplier of 1/3. And so that's my B value. And so because they're decreasing, I need to have a B value between 0 and 1, not a B value greater than 1. So the only choice that meets all the criteria is going to be choice A. Okay, the following exponential function demonstrates exponential growth. Oh, excuse me, it says which. I was like, what is the actual question here? Okay, so keep in mind, growth means that it's going to be increasing from left to right. And so for one thing, I'm going to need a B value that is greater than 1. Here, my B value is less than 1, so A is out, so is D. Now, B is a B value, like choice B has a B value greater than 1. However, if you drew this originally, that's fine, but you have a negative A, so it would actually flip over, and it would be decreasing as it goes from left to right. So then the only one that would be truly exponential growth is going to be choice C. All right, here we go. End behavior. We always need to know about this from the beginning of the year. Here it's telling you what? Well, as x goes to negative infinity, the left end, and this means is going down. And then here, when x is going to positive infinity, that's describing the right end, and that one's approaching 0. So if you sketched yourself a graph where the left end is going down, exponential, and the right end's going to 0, it would look like that. And in order to look like that, it has to have a negative A. So that means C is out and A is out because it has to have a negative A value. And then if you drew like what it would have been before it was flipped over, it would look like that. And that would require B to be less than 1. So of my 2 remaining options, this is the only one that has a B value that is less than 1. So sketch it out and then match up what you know about the graph with what your options are. All right, the exponential function k is defined by this. Which of the following statements about k is correct? Okay, so first of all, my a is positive, and my b, just because it's a fraction, still look at it critically, 2 over 7 is indeed less than 1. So I'm going to be looking at a graph that comes down from left to right, and now that I have a visual, I can answer the question. K is increasing. It is absolutely not. So I can get rid of these two. It is definitely decreasing from left to right, and this is concave up. Now, the other way they could have worded that is they could have said that it's decreasing at an increasing rate, because increasing rate is the same as saying concave up. So be prepared for that wording as well. Okay, 16, selected values of the function are shown in the table. Which of the following claim and explanation statements best fits the data? All right, well, let's look at the data. First of all, we check that these are going up by the same amount, so check. And then here, if you look at these are getting multiplied by 4 each time. So a half times 4, 2 times 4 is 8, 8 times 4 is 32, 32 times 4 is 128. So in this case, this is exponential, then our b is going to be 4. So best modeled by logarithmic, okay, we have not learned that, and so that's certainly not my choice. So is it exponential because the outputs over consecutive equal length input values, simply meaning that these are the same all the way down, are proportional? Or is it best modeled by exponential because the inputs over consecutive equal length output values are proportional? Okay. This is saying that the x's change by a multiplier. This is saying that the y's change by a multiplier. So if you look back, we have notes that exponential is characterized by proportional outcomes, meaning our outcomes have a multiplier between them. All right, in 17, the function g is exponential and it decreases at a decreasing rate. So this means it's actually going down from left to right, and this means that it's concave down. So I would probably sketch myself a graph. The only way that it can be decreasing from left to right and concave down is to look like that. So now, which of the following is true? These are end behaviors. So before I look, I'm going to think about it. My left end is approaching 0. My right end is going down, so it's approaching negative infinity. So pay attention. This is x approaching negative infinity. So this is saying the left end is going towards negative infinity. And since I thought about it ahead of time, that's not true. This is saying left end is approaching negative infinity. Not true. So I can rule those out. These two both are correct on the left end. The right end should be approaching negative infinity. So between these two choices, this is the one. So C is going to be the proper one. Drawing the sketch ahead of time makes it a million times easier for me. Otherwise, all these answer choices are so similar, it's hard to differentiate. Which of the following functions is an equivalent form of the function this? Okay, so keep in mind that our power rules allow us to split this up like that. And so then 4 to the third power is going to be 64 to the x power. So that is just about knowing my exponential rules. So here, which of the following is equivalent to this? So this is tricky because you can see here that all of these are in a base 2 and it starts as a base 4. Keep in mind, if your number is going to get smaller, you're going to need to square root that 4 to get a 2. And the square root of 4 is the same as 4 to the 1/2 power. So I can have my 9, and then I can write my 4 to the 1/2 power in order to make that equivalent to the 2. And so I'm thinking, okay, if I need to have a base of 2, let's think that through again. I would actually need to square that 2. I was going backwards. So rewind. What I said is all true. It just doesn't help that much because since these are base 2, I need to think like, how could I write my 4 that's here as a power of 2? And I would have to square the 2 to turn it into 4. And that would turn into 9 and then 2 here, and the 2 and the x would multiply together on the outside. And so that is going to be choice C. Hopefully I didn't screw you up too much on that because I was thinking backwards. After returning home from spending 2 weeks in Kansas City grading AP exam, Miss Arnold notices a large amount of algae in her pool and decides to add chlorine. The decreasing function, so that's probably significant, gives the amount of chlorine in her pool. The table gives values in parts per million for selected values of T in hours. This is so many words. Since Miss Arnold added the chlorine to her pool. If a model is constructed to represent the data, which of the following best applies? Okay, that is so many words to say which equation works for these values. So if you look, these are going up at a consistent rate. It told us it's decreasing, which is telling me that my B value is going to be less than 1, which I can see here. And if you look at these are dividing by 3, which will translate into a B value of 1/3. So these two are eliminated right away. And then it's saying that the only difference between these two is the power, you guys. You can see that we started at 54, and then, which we did, and then we know our B value is 1/3, but it tells us the table gives values of A sub T in parts per million for selected values of T in hours since she added the chlorine to her pool. So it doesn't say anything about 1 hour later or anything like that. So we're going to go ahead and choose C because that's just going to represent the time after she added the chlorine. 21, the function h is given by this bad boy. Which of the following is equivalent form for h of x? Okay, so keep in mind that you can separate this out into 3 times 4 to the x times 4 to the negative 2. And when you do that, you get 1 over 4 to the positive 2, which is obviously going to be 1/16. So you have a 3, a 1/16, and a 4 to the x. So when that's all kind of put together, here's what you would end up with, and that is choice A. So in this situation, because those powers were added or subtracted, not multiplied, I separate them like this. I keep the same base, and then a negative power has to move into the bottom to become positive. We're going to have to quit pretty soon for school, but let's see if we can knock out a couple more. A quadratic regression was used to develop a model for a given set of data. The figure shows a graph of the residuals. Okay, one thing to note is that this has no pattern. So that is good news. Which of the following statements about the quadratic regression is true? The quadratic model is not appropriate. Actually, it is appropriate because that's what no pattern means. No pattern is actually good. It means that the one you chose is the proper model. So we want to make sure that we choose one of these where it says quadratic model is appropriate. Why? Because there's a linear pattern. No, there's not. The idea is that we want to have no pattern. So that is going to be D. All right, 23. A set of data was used to create a linear, quadratic, and exponential. So you can see here that they have that. Except for up here, it says cubic. So we're going to ignore it and go by what this says. The residual plots above for the three models are shown. Based on the three residuals, which of the following regression models would be the best? Keep in mind that the best means no pattern to the residuals. So there's no pattern on the residual graph. So if I look at this kind of has a pattern, so I'm ruling that out. If I look at this kind of has a pattern, so I'm ruling that out. So this guy is scattered, no pattern, and that says cubic, so I am choosing C. Easy peasy, right? All right, let's hammer out this one, and then I'm gonna call it a day for now. The table gives the population in millions of a certain region for selected years. An exponential regression of the form blah, blah, blah is calculated for the 5 data points, where x equals 4 represents 2004 and x equals 8 represents 2008. Based on using the model to predict the future population, in what year will the population reach 35 million? Okay. So this is going to have to be a calculator situation because we have to be able to get an equation, and then we have to be able to graph to see where they are going to cross. Okay. So I'm going to go ahead and put this into L1 and I'm going to put this into L2. So this is a calculator multiple choice, which there are some on our test. When you do that, you are going to be doing exponential regression, and it's going to give you the equation 21.1486. 1,000%. You should be doing this yourself right now and testing to see if you get these exact values, because you should. So go ahead and try, enter these. Now, keeping in mind that you are entering the numbers like this. You are not entering in the full year. It told you right in here how to enter those. So you'll be entering 4, 8, 12, 16, and 20 into L1, and then these numbers into L2. You'll be going to stat to edit, to put those in, and then you'll be going to stat, calculate exponential regression in order to get this equation. Okay, we need that to equal 35. So what I would do is I would type this into my calculator. We did one like this in class as Y1. I would type Y2 in as 35. This is greater than 1, so you're going to have an exponential growth, and then you're going to have a horizontal line at 35, and you're going to use second, trace, intersect, and follow the prompts to figure out what X value do they intersect at. So try that, and you're going to have to really think about using your window and making it so you can see all of this, because you have to be able to see the intersection on your screen for your calculator to be able to find it. So try that. Make sure you can get 30.149. Everything about it should be exactly the same. You should have exactly these digits and come out with exactly this number. And so that represents the year 2030. So you would answer it like that. You would say it's in the year 2030. So let's stop for now, and we'll continue in a separate video. Bye, guys.